Welcome back to part 2 of the Electrolytic gold refining cell series of videos. This is a double refined pure gold bar, and I've decided that we're going to use this for the cathode instead of the titanium pieces that I bought because I'm not quite sure what's in this alloy. We're going to use this bar as the anode bar. This is from a recent video where I repurified a gold disc. We've got 58.2 grams. And what I'm going to have to do is figure out a way to suspend this bar in the electrolyte that will be in this beaker. And what I think we're going to do is I've got two 14K scrap gold rings. I'm just going to take these, cut them apart like this, and what we'll do is take this down to my jeweler friend, spread these out with a pair of pliers, and then have him weld these onto the anode bar, and then use these to suspend. That's kind of thin, that'll still work, to suspend our anode in the electrolytic gold refining cell. This is better left to a professional.
Really? Hard enough, yeah.
The whole block of gold, so you got to concentrate the heat on the bar in order to get the solder to stick to it. I got you. See, I wouldn't have been able to do this.
Let's see that shit.
There it goes. It pulled up into a ball again, didn't it? That's why I want a professional to do it. I just keep melting that thing over and over, Bob, until it turned into a big blob. Good.
You think that's gonna be alright like that?
This bar will be suspended in the electrolyte. I'm going to use these two dog ears that he's welding on right now to suspend the bar in the electrolyte. There it goes, man. I seen it.
Yeah.
Alright, we're just going to keep rolling this through the roller here. Squeezing down on it a little each time. This is the electrolyte that we made in part 1. We're going to begin the experiment by filtering the electrolyte. Once we get all the electrolyte pulled through this filter, what we'll do is get our electrolytic gold cell set up. I think what I'll do is move this heating unit up and put it into one of my casserole dishes. I've got a spotless 250 milliliter beaker. Drop in a magnetic stir bar. Here's our anode bar that we're going to use in the electrolytic gold cell. I've bent the little dog ears that we've welded onto it so that it will hang on the edge of the beaker. I was going to use this thinly rolled high purity gold as the cathode, but I think what we're going to do is we're going to go ahead and try the titanium turbine blade as the cathode for the gold cell. This is the brand new power supply that I bought on eBay. I think it was about 80 bucks. Came with these leads. So we're going to do a mock assembly right now and just set it all up and get it configured like we want it to run our electrolytic gold cell. The red lead is the positive lead, and we're going to hook that to the anode bar like so. And this is why we're doing a mock assembly, to make sure that everything is going to go smoothly, because it never does. Alright. There we go. Now we just got to find a way to keep that cathode from protruding out into the cell. I've got the mock assembly complete, and I think this is going to work okay. We'll be able to see the pure gold forming on the cathode at this angle. What I want to do is fill it up to electrolyte to about right here, and then we're going to add hydrochloric acid. What I don't want to do is fill it so full that it hits the little dog ears that we have welded on there and dissolves them, and then the anode drops away. So we got to keep the electrolyte off of these little dog ears. So now let's take this apart. Just get it out of the way. Here's our electrolyte gold chloride solution with about 25 grams of pure gold dissolved in aqua regia. I'm going to fill the cell up with the electrolyte to just below that line. Right there. I'm going to put the anode bar in here now. And what we want to do is add some hydrochloric acid. So we've got about 10% free hydrochloric acid. And here we go. I'm going to add hydrochloric acid to the electrolyte. I'm going to add some heat we'll start heating the electrolyte up. If this level gets too high, I can pull some electrolyte out of there and add it back into our flask, so we can adjust the level to get the proper level for the cell operation. All right, we got 127 Fahrenheit, 53 Celsius. The book calls for 140 degrees Fahrenheit, so we're almost ready to go. Let me set this back out of the way. Here's our titanium cathode. Let's see if I can hook this anode bar up. Now spoiling it. Got 134 degrees. I'm going to call that close enough. Turn the heat down just a touch because it's rising. Now we're going to put in our titanium cathode, and I don't know what's going to happen here. I hope this works. I'm going to connect the cathode, and now we're going to energize the power supply over here. I've got the power supply turned completely down so that there's no current flow. And what we'll do now, here we go. I'm going to start adding a little bit of voltage. It says the book calls for 1.5 volts. Point 3, 0.8, 1.1, 1.6. That's close enough. Got 4 amps going through the cell, so we should start getting some action here. I do see some blackening on the cathode. See that? Starting to turn dark, and I can see some material forming around the edges of the cathode in there. I believe we're starting to get a result here. The anode bar looks different now that we're passing the current through it. I've got the current flow set at 1.6 volts, and that cathode, the titanium cathode, is definitely picking up something. There's something forming on there. I was kind of scared of this experiment. I didn't know how that titanium cathode was going to work, but apparently looks like we're going to be okay. So far this is going pretty good for me. You can see the gold is starting to form on that cathode in there. Looks like little nodules of gold. And the anode bar is corroding away nicely for me. See that? We've got the voltage set at 1.6 volts, and we're running 4 3/4 amps through the cell. This is about, let's see, I started this about 10 minutes till, so we're almost a half hour into it. I think this is going to work out pretty good. I think I've I've got the right temperature setting on here. Got about 142 degrees Fahrenheit, 61.2 Celsius. This is about an hour and a half into the process. We started at about 10 minutes to 12, and it's looking real good. If you notice, the amps have dropped way off. So what I'm going to do is I'm going to try to add a little bit of our gold electrolyte, just a touch. I brought the amps up just a little bit of hydrochloric acid. That improves the conductivity as well. So we're going to add about just a little bit of hydrochloric acid, just a few drops, and that will increase the conductivity through the cell. This seems to have worked fairly well for me. That titanium cathode performed so far anyway. You can see here the anode is nearly all gone, corroded by the electrolytic action of the cell. I've been adjusting the temperature. Here you can see we've got the temperature about 144 Fahrenheit, 62.2 Celsius. Now what I'm going to do, I'm going to try a little experiment here. I'm going to try to crank the voltage a little bit and see if we can alter the crystal structure. That amps really jumps up when I increase the voltage. Got 5 amps going through there now at 2.1 volts. Alright, there's 2.5 volts, 6 amps going through the cell. I don't know how this is going to affect what's going on inside of there. With the voltage turned up like that, I do see a little difference going on in there. I see some sparkly specks of gold forming. Look different from the nodular stuff that's depositing on that titanium cathode. I'm not sure what this is going to do to my gold. Looks like it's turning color a little bit. I think what we'll do is turn this voltage back down a little bit. That's close enough. We'll let this anode completely corrode away. And then we'll get our cathode that's coated with high purity gold out of there. Give it a look. You can see the anode bar is corroded away, and it looks like a shark's tooth. And the cathode, the titanium cathode, performed well. Looks awesome down in there. I think what I'm going to do as a experiment here at the end, time right now is 20 minutes to 2, so almost 2 hours to get this far into it. What I'm going to do is I'm going to crank the voltage here, get it up around 7 amps. Oh, there's 8, 9. Whoa, better watch it there. Too high. Now look at the anode corroding away. It's literally dissolving away with that high current flow. It's taken about 2.5 hours to get this far. We started at 10 to 12. It's about 10 after 2. And if you look down here, you'll see that the anode has lost its footing. It's no longer clipped onto the edge like I had it. That's probably because of the weight reduction. You see the anode's just almost completely dissolved now. Let's turn the heat off, the stir bar off. And now what we'll do, I'm going to secure the power supply, and I'm going to pull the gold up out of here. Get the rest of this anode bar out of here before it falls down into the electrolyte. There's the anode bar. It's like a shark's tooth. Let's see, how are we going to do this? Let's move this over out of the way. Push my power supply back out of the way best I can. Make some room. And we're going to pull the electrolyte down off of the heat source here. Now let's take a look at this gold that we've accumulated on the cathode. Let's go ahead and rinse the electrolyte off of here. See what the back looks like. Well, the back's even got some gold sticking to it. I just hope we didn't glue the gold firmly to the cathode. Here's our high purity, electrolytically refined, should be about 4/9 fine, pure gold. Let's go ahead and rinse this off real good again. Just make sure we got all the electrolyte rinsed off of it. I'm just going to set this over here for right now. Take this is our electrolyte. I'm going to add it to this 600 milliliter beaker. Get in a hurry, make mistakes. You can see this still got some electrolyte on it. Let's get this stir bar up out of here. Let's go ahead and put this back into this beaker. I've rinsed it out and cleaned it out real well. We're just going to let this soak in some distilled water to try to get all the electrolyte off of there. This is going to be gold, so I'll save that and put it in my paper storage. Alright, let's get down in here. See how hard this is going to be to get that gold to release from the cathode, the titanium cathode. It's just a bamboo skewer that I'm using here. Let's see how hard it's stuck. Yeah, it's stuck in there pretty good. There we go. I'll just keep working with this until I get the gold to let go completely. That's what it looks like underneath. Let's move this out of the way and make some room for the electrolyte in this beaker. And what we'll do now is I'm going to add some stump out and recover the gold that we used for the electrolyte. Stump out is sodium metabisulfite. I'm just going to add a spoon of it into the electrolyte. We're going to precipitate out the pure gold. This should be high purity gold, about like 3/4 of an ounce. Just set this over here out of the way, and now we'll bring our gold back up, continue working on it, and try to get the gold off of the cathode. That's one bad thing about using the titanium. It's not really sticking to the cathode, but it's just hard formed gold. There you can see that's coming off real easy in the back there because it's real thin, but this thick stuff up front is really sticking pretty good to it, only because it's metal that's formed around the titanium cathode. It's not actually sticking to the titanium, it's just formed around it a hard crust that's hard to get off of there. Having to resort to using a stainless steel spoon, something that's firm enough to be able to break the gold apart so it can come off of the cathode. There we go. We got it off. Here's our high purity 4/9 fine gold. It's amazing looking. It's solid metallic gold. that is plated out onto the cathode. You can melt this up into a pure gold bar, just like it is. Here we go. Let's put our 4/9 gold in a melt dish. Cooperate. Let's take it over here to the melt table. We're going to melt this up. A nice little ingot out of this high purity gold. Ultra high purity gold. Absolutely beautiful. Electrolytically refined in our gold cell. We've got 45.6 grams in this ingot. And we've also got some other gold here that we recovered. This is the gold that I rolled out to try to make an anode bar. That was pure gold. There's 57 grams, and then we've got the gold that I precipitated from the electrolyte that we used to refine our pure gold ingot. It's probably going to be about 25 or 30 grams of pure gold in here as well. All right, this will conclude the video. I'd like to thank everyone for watching.